Here we are with the second part of second chapter, or we can say second video on business statistics, and we are here now explaining the data representation. Uh, that we have already seen that what we mean by data, and now if we have collected the data, then how can we represent that data into different forms? So this lecture is specifically focusing on the data presentation. We will do manual exercises and as well as computer exercises, and that computer exercises will be done on Excel sheets. But first of all, we should see the manual exercises on data presentation. What are the data representation methods? There are different methods we can represent the data. If we have collected the data, if we have collected some facts, if we have collected some numbers or counts on some particular variable, we can present that variable into different forms. It may be table design, it may be bar charts, it may be histogram, it may be pie chart, line graph, scatter plot, etc., etc. So let us start with the tables. Tables may be of many kinds. Uh, Here I am giving you just glimpse of that table into three forms. First of all, it may be a simple distribution of a percentage into a different categories, such like that, in where we have distributed the regions, and we have calculated the regional difference in the percentage of the adults taking a holiday in 1998. The source is given. So these are percentages have been distributed among the different regions. So this is very simple and very good representation of data. Rather showing you the complete all series of number, we can summarize that series of numbers into a simpler form of a table. It may be a simple summary of descriptive analysis or descriptives of any series containing mean, median, mode, standard deviation, skewness, kurtosis, maximum number or minimum number, and so many more things. So the table we are going to make, it depends upon our need, it depends upon the nature of data. Or it may be a simple frequency distribution showing the frequency or a number occurrence in each several categories, and the frequency distribution are used to summarize large volume of data values. You can see that the 902,075 observations are being classified into some kind of interval classes. So this is a very good technique to present huge data into one form of table. So these three are the different kind of tables. We may have many more so. But here in the statistics, initially we will be doing in such manner that we should understand all these kind of a table. So before doing the manual practice, first of all, we see some kind of a charts and graphs as well. What we are going to make in coming videos. It may be a bar chart histogram that the data we have shown you in the last slide, or that can be also shown as the graphs or the charts. One of the kind of the graphs are pie chart, a bar chart or histogram, or it may be a pie chart where we uh, distribute percentages into given amount of a magnitude and covering some kind of area of the circle. We can show the distribution of a number in percentage form into different categories through the pie chart. And as we can represent our distribution of a number or flow of a number into some kind of a line graph as well. So these are the different kind of representation of data, because data by itself is very confusing and not understandable. But when we represent that data or series of numbers into such kind of a formal form, So the understanding of that series is become somewhat easy. So let's start the practice. First of all, we would like to establish a frequency distribution. Frequency distribution, it comes where some kind of data is being gathered or collected, but those numbers or those digits cannot be presented in a very rough way. We should present those numbers or those data or that series in form of a frequency distribution, which is very good presentation of any kind of a series. So frequency distribution shows the frequency or a number of occurrence in each of the several categories. Frequency distribution is used to summarize large volume of data values. As I showed you in the last slide, that the frequency distribution where we distribute the numbers into different kind of interval or categories or classification. And when the raw data is measured on the quantitative scale, either it is in interval or ratio, categories or classes must be designed for the data values before the frequency distribution can be formulated. So this is a process actually. This is the process where we go for creating a frequency distribution. There are some things which has to be in mind before doing this classification. What are the steps in creating frequency distribution? Let's see. Uh, Step number one. First of all, if you have a data series, first of all, you have to arrange that data or arrange that series into ascending or descending order, uh, uh, specifically in ascending order because it look normal and quite well when we are having ascending order series. Uh, Step two is calculate the range of the data. Range of the data mean that the difference between the maximum number and the minimum number. It is called range because when you are you have done with the data series to sort out in the ascending order, so you can easily find out the maximum number of the series and the minimum number of series and get the difference between those maximum numbers and minimum number. You will get the range of the data. Range of the data tells us that in how much bigger picture we can grasp our data into simpler form of a table. uh, Step number three is decide the number of classes or interval in the frequency distribution. When have we have calculated the range, after that we have to decide how much classes we have to create in the series as interval classes and as a frequency distributions. Then we have to define or determine the intervals. That is a process we will show you in a while. And after that, make a column in the table of interval and frequency. You have to make a column. You can do it manually on the paper through pen or pencil, or you can go you can use the uh, computer spreadsheet or any kind of a word format for the creating a table. And after that, sixth step is when you have created the table, you can now tally and count the observation under each interval. So this is actually the process of making a frequency distribution, and in the end you'll get this kind of a table. So let's start with this manual kind of practice in creating a frequency distribution. uh, what are the process? Let's see. We can start with a series of data, and that is in the picture, in the slide. You can see that the 100 observations are being recorded or being collected from somewhere or some kind of a data. It may be the age, it may be the income earned, it may be the saving, or it may be the consumption expenditure, and what it may be anything. But you are having 100 values, and these 100 values have not any order, and Now we want to make a frequency distribution, and we want to present these 100 values into some proper acceptable manner. So let's start to follow the process of frequency distribution. The first step is to sort out the data in ascending order. If you are using any software, you may not need to do so. It means that uh, uh, if you're doing it manually, so it is better to make it in ascending order. But if you're dealing with the large data, so large data cannot be easily dealt in manually. You have to obviously go through some software use, some kind of Excel kind of spreadsheet or any other software. So here we are having a little number, we are having 100 observations, so we can do it easily, manually even, that to ascend, that to make an order in ascending series. So that is being ordered ascending. You can see that these numbers have been arranged in ascending order, starting from the minimum value 0. Here we can see that here is the 0, which is the minimum value of this group, and the maximum value as 90. So manually with the naked eye, it is very difficult to locate the maximum minimum number with this scattered or with this unsorted data. But when you sort this data out in ascending order, you can easily find the minimum and maximum value. So in the step 1, we have arranged this data into ascending order to find out the minimum value and the maximum value. So minimum value is 0 and maximum value is 90. In the second step, we have to calculate the range of data, and this is the formula where the maximum value subtracted with the lowest value. In our example, maximum value is 90 and lowest value is 0. Here we can see that is 90 and this is 0. So 90 minus 0 becomes 90. This is our actually the range of our data. So if we have calculated the range of data, then we have to go to the step number 3, where we decide on the number of interval or classes. Now this is up to us that how many classes we have to we are going to create in the frequency distribution. Here let's say we are going to create 5 classes. You can make 6 classes, you can make 4 classes, 7 classes, 10 classes, as much classes you want to create, you can do so easily. So when you have decided that how much the classes we have to create, just remember the figure we have to create here in particular example as 5 classes. So next step is to determine the interval of the class, because each class would be having some interval, would be having some kind of a range. So for that class range or interval of the classes, there is a formula that the range we have calculated above, which is 90, that should be divided with the classes you have determined. So the range is 90 and the classes here we are determined to have is 5. So range divided by classes, that is 90 divided by 5 is equal to 18. That 18 is actually the interval of one class. So we'll be keeping this interval constant to all of the classes. Every class, every group will be having the range of 18 difference. You can round this value as per your convenience. Here we keep 18. You can round it to 19. You can round it to 20. But here we do not rounding this value. Here we are taking as it is, where we have divided our range with the classes, and that is 5. So 90 divided by 5, it becomes 18. So we have calculated the interval range of each class. Now the next step is make a simple class table of classes with the determined interval, because we have created interval 18. So you can see that from the first class it is starting from 0 to 18, and then second class is starting from 19 to 36. Obviously the difference is the difference is 18. Then the next class is from 37 to 54. Then the next class is 55 to 72, and the next class is 73 to 90. So you can see that we have created some frequency distribution where the interval of each class is 18. So when we have created the class with the 18 interval, 5 classes with the 18 intervals, so now we are able to create tally and count each observation under each interval. So this is the telebar. Telebar means that you can find out the bars into the cells. It means that you have to locate, let's say, from the first class, it it covers from 0 to 18. So here we go to the table, sorted table. We can see that 0 to 18, we are having 0, 9, and 15. These three values are coming into our first classification. So here are 3 bars, and 3 bars means that 3 is the frequency. It means that there are 3 digits or 3 observations which belongs to this group or this range of group. Similarly, if we go to the next range, next class or next interval, that is from 19 to 36, so here we start to count from 19 to 36. Here we start to count with the starting from 22. So from 22 up to 36 is the maximum value. Here we see that 36 is coming over there, 37. So 37 is not in this class, so I'll be taking these values 1, 2, 3, 4, 5, 6, and 7. So 7 bars uh, I have drawn in the cell because I'm counting one by one. Any with one observation, I put 1 bar. So total bars for this class is 7. So the frequency of this class is 7. It means that 7 observations into this sorted series, or is in unsorted series, there are 7 digits or 7 numbers or 7 observations. They belongs to this group from 19 to 36. Similarly, the third class is from 37 to 54. Now third class is from 37. So we'll be starting here. 1, 2. I'll be counting 1, 2, 3, 4 and making bars over there. And we can see that for the third class from 37 to 54, there are 37 numbers, 37 observations. So if I'm starting from 37, so 37 numbers till 54, this digit. So I'll be putting 37 bars, and by counting, I'll be confirming my frequency. That is 37, and 37 mean there are 37 observation concern or observation belongs to this group. Similarly, we are doing the same practice for the next class and the last class. Here we have calculated the frequency concerning for each class or interval. And if we add this frequency, we should get the total number or total of this column as equal to the total observation into that series. So this is a simple practice of frequency distribution. So I think it would be now easy if you are given some similar sort of data, a small piece of data. Obviously, we cannot do the same practice or same manual practice when we are given the large amount of data. Here the values are in 100 observations, so we can do it easily. Manually, it can be practiced within it will be taking almost 10 to 20 minutes, but it can be happened manually easily because the number of observations are not that much large. And now if now when we have created the frequency distribution, so from this frequency distribution we can calculate many more things. uh, very readily we can create absolute frequency distribution, what we have done so far, that is absolute frequency distribution. You can see that we have done this uh, mm, we have created this kind of a column through some through that practice. So after having this frequency, we can also sorry we can also go for bar chart. So you can see that these classes are being scaled on the x-axis. You can see that 1, 2, 3, 4, 5 classes, and these 5 classes are being scaled on the x-axis, and on the y-axis, uh, this frequency is being scaled. And point to be noted that this scale should be developed in such a way that the maximum value of a frequency should cover up. So maximum value is 49. So we have created this scale up to 60 with the equal interval of 10. So 10, 20, 30, 40, 50 and 60. We have taken to 60 because that 49 coming under this 60. You cannot, you can miss the 60 as well. You can come up to only 50. But here we can do according to our requirement. So when we have established these scales on the x-axis, we have scaled the classes, and on the y-axis we have shown the frequency. Now we can make a simple kind of a bar with the help of marker, with the help of a pen, with the help of a pencil on the paper, simple paper board. So this first class, this first class, which is starting from 0 to 18, it is having a frequency of 3. So here you can see that on this first class, I have just created a small piece of bar uh, showing up the frequency of 3. And similarly, when we came up to second class, which is from 19 to 36, and that containing the 7 frequency, so that bar is giving you up to the 7 of frequency with this any kind of a color. Next, with the 37, you can see that the third class from 17 to 54 is having 37 frequency. So you can see that it is near to 40, and this height of this bar is showing you the 37 of this frequency. And for the next one is 49. So you can see that the height of the bar again increased because of the it is near up to 40, 50. It is 49. So this is frequency distribution for fourth class, and the last class is from 73 to 90, containing 4 observation or 4 frequency, is again drawn like that. So you can do it manually, but that manual practice is possible when the number of observations or the class size is very much small. But when class sizes become when class size become large, you cannot do this you cannot do this practice manually easily. So when you have gotten the absolute frequency, then you can create a relative frequency. Relative frequency means that where we do not want to know the count, we want to know the percentage. So here we have calculated the percentage. It's very simple formula: frequency divided by total frequency. So this is our frequency. It is 3, and divided by its total, that is 100. So 3 divided by 100 becomes a 0.03. It means that in total counts, 3% of observations belongs to that class, 0 to 18. Similarly, that 7 from in the second class, this 7 frequency is being divided to 100, we get 0.07. It means that 7% of the observation belongs to the second interval. Similarly, 37% observations belongs to third group, and 49% of the observation belongs to 55 to 72 interval, and 4% of our what we can say that our observations belongs to this particular group. So this is what we call a relative frequency. This relative frequency are, you can say that the basics of if we are going to introduce probability here, but right now I'm not gonna explain you the probability, but that percentage we can use in many kind of cases. So if let's say if I'm asking you that can you tell me that how much uh, mm, percentage of the observation that's belongs to first two groups. So you can say that 7 plus 3, these are 10%, 10% of observations that belongs to first two classes. So you can cumulate this frequency, so that becomes a cumulative frequency. You can see that. And next is cumulative frequency distribution. It means that this frequency is being established again by adding additional value of the frequency of upcoming class. It means that from first class it is 3, but from the second class 7 more observation are being added. So first two classes are having 10 observation. So we got 3 plus 7, and we got cumulative frequency. Similarly, when third class added, so from addition of third class, so 37 more observation are being added to this 10. So we can see that above three classes contain 47 of digits. And similarly, when fourth class coming into scene, and with the addition of this fourth class, 49 more observation are being added to the group. So that becomes 96 in total observation. It means 96 observations are contained in these four groups. And similarly, the last groups when comes in, so four more observations are adding up to this group, and that's how we can see that all the 100 numbers are containing all these groups. So cumulative frequency distribution, we have added each frequency in the previous addition, so we can see the shows the total number of occurrence that lie above or below on any certain level of a key or a certain level of classes. That cumulative frequency can be repeated to the relative frequency as well, when where we have talked about the percentages. Cumulative relative frequency is the accumulation of the previous relative frequencies. It is having the same formula where we have applied to this. So uh, we can we can add this relative frequency by having addition classes. So first class is having 3%. We can say that the 3% of the observation are belongs to first class, but when second class comes in, then in total 13% observations, because from the second class uh, 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 I think there's somewhat mistake over there. Yeah, it should be 10. It should be 10. Yes, it should be 10. So 10% of okay, 10% of observations belongs to first two classes, and when third class comes in, so it makes 47 observations. So 47 out divided with 100, that makes 0.47. It means in total 47% observations belongs to first three classes, and and so on and so forth. And the last, obviously, last group will be having 100% of observation in with all these groups. So this is called some kind of information. We can use these information into different kind of a manner, but here we are up to only to see the estimation and process of calculation. So here, guys, we have created a frequency distribution along with some additional column of relative frequency, cumulative frequency, and cumulative relative frequency. Now, here is an assignment for you. See, these are 144 observations of numbers of any data. You have to make a frequency distribution. You have to calculate relative frequency distribution. You have to calculate cumulative frequency distribution. You have to calculate cumulative relative frequency distribution, and in the end, you have to plot histogram. So this is your home assignment, and you have to do it manually. But after that, we will go to the larger data where the manual calculation or manual handling cannot be done. We'll be using Excel series, Excel sheet for such practices for the larger data. But so far, you are given this data series, and the requirement of these five uh, uh, questions or five kind of a requirement you are given. You have to do it manually and send that manual calculation on the due date of assignment. Thank you very much, and soon we will be having some uh, computer exercises with the larger data. Thank you very much. Okay guys, this was your last assignment, and you did you had to do some task on that. You had to create a frequency distribution, cumulative relative frequency, cumulative frequency distribution, and cumulative relative frequency distribution with histogram. But this assignment was about having 144 observations. So as I said that when the data is small enough that could be handled manually, you can do so. But what about when we have such large data? You can see that here I am having almost 1126 observations. So if I am having such bigger or larger data, I cannot do such basic statistical practices manually on the data. We need some kind of a computer help. So now I would explain you how to do some basic statistics on this data, descriptive statistics on data, and with some requirements using Microsoft Excel. So now we will do a computer exercise. And one more thing, that when we are using computer software or any package for estimation regarding any requirement, so we can do many more things. Rather, we had done little information like doing only frequency distribution and their cumulative values and the histogram. But now I'm using the computer Excel sheet computer system, so I can do many more things. I will do it just to show you that how can we deal with the data. First of all, I would go for plotting scatter diagram, because you didn't do this scatter diagram manually, because it is not possible for any individual to plot scatter diagram on some manual sheet. So you need to take help from the computer system like Microsoft Excel. Along with this, we will definitely create frequency distribution. This was a basic basic aim and objective of this lecture. And then we would go to calculate cumulative relative frequency. Then we will calculate cumulative frequency distribution. Then we will calculate the cumulative relative frequency distribution. Then we will plot histogram. Probably this histogram would be done along with the frequency distribution, because computer software or Excel sheet provide us this tool into one go. So we will do this. We will plot this histogram along with the frequency distribution. Then we will do some practice on pie chart, and in the end we will do create a line graph, and what all these things would explain, let's see. So starting with the uh, uh, starting with this data. So okay, this is actually our data, what I have shown you in the last slide, and now I want to make some my requirements of statistics, basic statistics like frequency distribution and their cumulative values with some kind of charts. So if I am doing practice in Excel, so such kind of presentation, having my complete all data into 34 or 35 different columns, so that would not be appropriate according to Excel need, because Excel sheet or any kind of spreadsheet would take one column for one variable. If I take it as it is, it would by default would take this data as having 35 different columns, and they would take as 35 different variables. But I know that I have only one variable of age, so that data has to be explained or has to be shown in one column, just as this. Now you can see that all those 1196 observations are now I have posted on one column. If you see that if I am going to the last value, so that would be 1196 observation. So all that data have come into the one series or one column. Now I can do many practices of mathematics and statistics by taking help of Excel sheet. First of all, we have to draw the scatter diagram. Now what a scatter diagram is, and how it is shown, and what this scatter diagram is telling us. Let's say first of all get the scatter diagram by first of all take the selection of all the data by keeping your cursor on that cell, then press shift, and by pressing the shift, press the shift, then press end, sorry, press shift, then press end, and then press down arrow. So you can take complete selection of the variable. So now you have selected the variable. Now you can go to the insert and insert menu. You can see in the middle there are some option of graphs and charts. Here we can see bar graph, here we can see line graph, here we can see different kind of graphs, but I'm interested to have a scatter diagram. So here I'm pressing the scatter diagram. In the scatter diagram I'm having different options, but here I will be going on the simple scatter diagram. So I'm pressing the simple dots. So by having simple dots, a graph has been made. This graph is simple scatter diagram. So what this scatter diagram is telling us is just showing us the spread or scatter of these observations. You can see that on the x-axis you are having from 0 to 1200 range. So what this range is, this is actually the series number of observation. This you can see that on the A column it is starting from 1 and it is ending on the 1196, is almost near to 1200. So this is this x-axis is explaining this observation series, and y-axis here, this is actually actually showing you the our required or target variable, that is age. Now that age is it is around from 10 to 90 almost, and now how this scatter diagram, what the scatter diagram is telling us, this is something a different kind of detail, but here for the purpose of having just a glance view, I can just go to each point and can see their relative position. let's say I'm having this point, and when I go to this point, a little information box has been opened. It is saying that the series is age with the point number 101,010, and that 101,010 point is having the age of 88. So it means that on the scale, on the series, 1110th point is having age of 88. So we can see that 1110. So if I go to the here, 1110th observation is actually the 88 of age. So actually this scatter is showing you with the bigger range of the series, from starting from 1 to the last observation, and on the y-axis the actual values of the variable are given, and then you can see anywhere, anytime, any data, any point, you can see here that this point is showing you the same column of age with the point number 589, and that point number 589 is pressing the age of 42. So this is actually its simple scatter diagram, and this scatter diagram is also telling us the normality and abnormality of the series, but I would not explaining the normality and abnormality of the series because it is very earlier to explain. I would go to explain normality or abnormality of the series, but later on, then when the time when the right time comes. So guys, this is scatter diagram. Our second last job is to create frequency distribution, so I am just deleting it here. So for having a frequency diagram, first of all we need to have to look the steps. So let's see where the steps we can see. Yes, now you can see we are having some kind of steps. If you remember, we have gone through some steps over there into manual practice. If you have remember that step 1 was to find out the minimum value and maximum value. That was our first step, and the second step was to get the range, and the range formula was the maximum value minus minimum value. You have done the manual practice, you know the meaning of all these things. And step 3, it was the determination of classes. So here we would determine the classes, the number of classes what we want to have in our series, and the step 4 would be calculating the class interval, and the class interval formula was the range has been divided by the classes. So we'll do it, and rest of the steps would be done on the data analysis option. So here I would take a start from initial calculation. So if I go yes, okay. So first of all, how can I get the minimum value of this tree, because it is quite not easy to see each and every column to find out the minimum or maximum number. One method is to sort this column on the ascending or descending order. We can do it easily, and from that we can also find out the minimum value and the maximum value. But I would rather go not to have this sorting out the series. I would go to have that maximum value and minimum value through functions. So if we locate our minimum value, so I would like to give the formula, and guys, this is your first lesson and your first step, that when I give the sign of equal to any cell, if I start my syntax with the equal sign, it means that I am giving the formula to the Excel sheet. So after giving this equal sign, if I press anywhere, you can see that this cell has been taken as the unit formula. So here I would go for a function. What kind of function I want to have? I want to have this minimum value of the series. So I would write the function of minimum, min stands for minimum, then starting parenthesis and after starting parenthesis I have to show in the Excel sheet the range of my complete data. So this is my first value, that is on the B2 cell, that you can see that is B column and the second row. So B2 cell up to the last one, and here I can do by writing syntax and as well as by taking the selection of all columns. I can do in both way. So if I want to give the range of the data to this column, so I would like to establish here as again B2, but now I want to tell him, I want to tell this sheet that it is starting from P2 cell, but it is ending on B1197, because I know that my 1196 observation is on the 1197 column. So I am just closing it down. So I have given the range, complete range. You can see that the selection has been made from B2 cell to the B cell of 1100. Sorry, this is not 1000. I think it is. So now this is complete range of data series. Now just pressing enter, I would get the minimum value of the series. So 17 is age that is minimum in this series. Similarly, for maximum value, again I would starting this cell by pressing equal sign, max, starting this with the parenthesis, and again I would press this first cell, colon, and then 1197, closing it down and putting enter, that is 88. So I got the minimum value, minimum age and maximum age from my data. So for frequency distribution, first step is done. We have got the minimum value, we have got the maximum value. Now the second step is to have range. Now what is range? This is actually the difference between the maximum and minimum age. So for difference, I am again putting the formula. This is equal sign, this is maximum value, minus this is minimum value, and enter. So my range is 71, and after having this 71 age, I am going to the third step while defining the classes. How much classes I want to have it? So let's say if I want 10 classes over here. So keeping 10 classes in mind, then now we calculate the class interval, and you know the formula of class interval, that is that range divided by the classes. So when I divide range to the classes, I would get the class interval, and that is 7.1, and 7.1 I would like to round it up to 7. So guys, I have rounded this up, so it may be, it is not it is not error, it is not a mistake, but I can round it up. But by rounding this value, I may have not accurate number of classes as I required. I may have 11 classes, I may have 12 classes, I may have 9 classes, because whenever I rounded the values, then this round value multiply with some kind of errors, and then my requirement can be changed. So let's see how much classes it produced, but my requirement was 10 classes, but the system can alter this class number because I have just made some kind of alteration in the calculation. So let's see how many classes it creates. So the step 4 has been done. Now in step 5 I have to set the bin range. Bin range is actually the bin range is being explained as classes. So here I am going for classes, and by having classes, now I want to have determine from where first class would be started. That should be started with the minimum value. You can see that minimum value is 17. Then my first class should be starting with 17. Then after that 17, you have determined the interval as 7. It means that now you add 7 into 17, that makes 24. Our second class would end up to 24. Then again add 7, 24 plus 7, that is 31, and then again that is 31 plus 7 equal to 38. So that's how we can go for more classes, and let's see in how much classes it would cover my maximum value range. 87, unfortunately 87 is not our maximum value. I had to go for another class, that is 94. So this 94 is covering our maximum value. Now let's see how much classes has been defined. Sorry, class 1, that was class 1, that was class 2, then this was class 3, sorry, and now if I go for my range, so here we can see that we have created 12 classes. My requirement was 10 classes, but here I have produced, the system has been produced has produced the 12 classes, because there are some minor variation or alteration in the calculation can figure it out with the different outcomes. But there is no problem. We have created the classes, which is actually called a bin. It is called a bin range. So this is called a bin range. So now I have completed 5 steps. In step 1 I have calculated minimum maximum value. In step 2 I have calculated the range. In step 3 I have calculated the classes, I have determined the classes. In step 4 I have calculated the class interval. In step 5 I have set the bin. Now I can do the frequency distribution. For frequency distribution, go for data, and data you will find here on the right upper column, that is data analysis. If you can't find this data analysis in your Excel sheet, if you cannot see, then you have to go to file. In the file you have to go to the option. In option there is a dialog box. In that dialog box you have to go to the adds in, and when you press add in, this again another dialog box is opened, and here you will go for go. Now this box has been opened. You have to check all of it, because it is checked in my system. If you will find such like that unchecked cells, and you have to check all of them, at least upper 4, but I am checking all of them and make it okay. You will find the data and the data analysis over here. Okay. Then now I want to create frequency, and I told you that the frequency distribution would be accompanied with the histogram. So when I click OK, a dialog box has been opened. I am going to the histogram. That dialog box is having so many statistical operations, but here I am interested only on histogram. I can do many things. I can do correlation, I can do regression, variance, descriptives, but first of all I am interested in frequency distribution and histogram. So here I am selecting histogram and OK. Now this this box is requiring us input range. Now what is input range? That is actually the complete series with label. I am just pressing the label because I want to show the label as well. So if by pressing this label, now here keeping my cursor here, you can see the blinking cursor over here, then come to the edge, that label name, label cell, then go to the end observation by keeping press the shift button, by keeping it pressed, then go for end and press down arrow. You will get complete range of the data. So I have given the range to the input range. Now the second requirement is bin range. Bin range is actually the class range. So here I am giving information about the bin range. This is my bin range, and here what would be the output range, where the output I can see, I can visualize the output. So here I am just putting my cursor over here by clicking this on, and I want to show my result over, let's say here. You can go for any cell, but I would like to have my data or my results over here. So if I've given the output range, and here's some more information are there, we can see the Pareto sorted histogram, we can cumulative percentages, we can go for the chart output. So cumulative percentages I can also calculate from over here. We can do by manual, we can do by system. I'm just putting it on the chart output, I'm putting it on the cumulative percentages just over. So by clicking these two options on and I'm just pressing OK, I would get my results. Okay, so here you can see that the frequency distribution and cumulative percentage is being established, but right now I am not interested you to explain right now all this stuff with having a multiple charts. I am going again and I'm just deleting it on. Okay, I'm doing it again for you. Go for data analysis. In the data analysis, all information is being given to that. Now I'm just putting my output range over here. Now I am not interested to have cumulative percentages yet. I'm just clicking it chart output only and just press OK. Now we'll get again same information, but now you are not having cumulative percentages, but you have some kind of histogram over here. That histogram can be explained if you can move the size of the diagram, then you can have this histogram over there. So this is frequency distribution we have done. That complicated task, if I would have done it manually, that was near to impossible, but here by clicking some good clicks you can find the frequency distribution easily. So guys, this is actually frequency distribution. Now the remaining task is just to have some kind of visible and some kind of more interesting visuals of that. I'm just here copy this frequency chart. I'm just copying it and coming to the my this column here. I'm just going for paste. Sorry, let's see if I'm doing it copy again. Just copy, then coming over there. This is frequency. So guys, you have got the frequency distribution, but one little thing is being again required alteration. Well, now what is that? You can see that classes is showing only one number, but when we did the the frequency distribution manually, the class was showing the complete range. So that range should be defined over here. We know that the class interval is 7 almost. We know the class interval is 7. So we would keep in mind and we would change the class interval according to the requirement. First class should be started from 11 to 17 because 11 to 17 covers 7 digits, and that is actually the class intervals. So this would be our first class. Then second class would be starting from 18 to 24. Then the third class would be starting from 25 to 31. Then the third class would be starting from 32, 38, and keep doing it to the last. That would be starting from 39 to 45. That would be started from 46 to 35. You can see that where the class is being ended 45, I am starting next class from coming digit 46, and then here 53 starting point or a lower limit up to 59, the upper limit. Then it is from 60 to 66, then from 67 to 73, then that would from 74 to 80, then 81 to 87, then 88 to 94. So this is actually class frequency distribution. So if I would copy it and take all this information onto the new sheet like there, so this is actually the classes and frequency distribution of that 1126 observation. In the last, I must have the total of it, and that total can be done through formula by taking auto sum and putting enter. 1196 observations are there, and that observations has been classified into frequency distribution. Now what this frequency distribution is telling us, it is very simple to understand that the first class, which is having the range of age from 11 to 17, that contains 25 persons. It means that 25 people or 25 observations or 25 persons belongs to the group having age between 11 and 17. Then 187 people or persons belongs to the group of having age from 18 to 24. Then 216 people or persons belongs to the group having age of 25 to 31, and so on and so forth. Only one man or one person belong to the last group having the age of 88 to 94. So that's how this frequency distribution is telling us the story. And same can be same can be equally seen if I go to have a copy of it. Let's say yes, come on. Same information is where can I can copy it. Let's see if I go for Control C and here I Control V. So this is our histogram. Same information is being shown in the histogram. You can change the size of the histogram. You can see that all the numbers shown in the frequency distribution that is being graphed through the bar chart that is called histogram. You can see that the first class, which is ended on the 17, it contains only 25 people, so there is a height according to the figure given. And the second class, which is ended to the 24, is starting from 18 to 24, so that may contain almost less than 200, which is 187, and so on and so forth. This frequency distribution or histogram is telling the same story. After having this frequency distribution, I want to calculate relative frequency, and you know what the relative frequency means. Relative frequency is actually simple. It is the division of single frequency divided by the total of frequencies. You can see that. Similarly, here it would be 187 divided by, and so on and so forth. You can see that all the stuff has been done by itself. And if I go for good visuals here, so if I do calculation like that, so it will be giving us the relative frequency. If what was the formula of relative frequency? That was frequency divided by the total of frequency. So if I put equal sign and just press it OK, and again I am putting the equal sign and press enter. And similarly, if I go for again here, if I go again equal sign, if I go again for equal sign, I can do it one by one, but I can also use the formula over here. If I put a lock on the total and putting the formula in the cell, I can do it easily, calculation by that way also. But here I'm just putting the equal sign in the start of the formula. I can do it easily here again. So there is one other method you can do it easily. Let's say if I do some kind of a help from the function, just go for equal sign and click on the frequency distribution and divided by the total. This is the cell of total, but total cell is repeated to the all columns, so that the total is locked for all columns. So for locking this cell down, we have to put the sign of dollar in between the column and a row. So if I do it again, I am having the same calculation. Now I am just dragging it down, and I may have simple calculation as it is. So I can do both method. I can put the formula, I can do manual like that, what I've done it. So here I can remove one column, because there's not needed to have double column over here. Okay, so this is actually the relative frequency, and you know how can we calculate the cumulative relative frequency, and cumulative relative frequency. So for cumulation, you know that we had to have first cell as it is 25, because it is 25, this is 25. But from the second column, we have to add in this 25 to the sorry, I have mistakenly, yes, okay, from here this is actually the first value of 25. Then I am sorry, this is mistakenly I have pressed enter. So this is 25 actually, this is 25. Now putting plus sign and add the next frequency. So you can see that I have added the 25 into 187, that is 212. Keeping it on, this is cumulative frequency, and in that cumulative frequency it is added the next one. Press enter. So that's how the coming frequencies are being added into each column, and you would get complete range of cumulative frequency. It is starting from 25 and ending on to 1196, which is the total of
frequency. Similarly, if you want to calculate the cumulative frequency distribution, same formula. First would be as it is what the relative frequency is, and then from second you have to just add the next one. I just click it on the after equal sign. I have clicked the this value plus the coming value, not the frequency but the relative frequency. This is okay. Enter. Then again starting from equal sign, clicking on this one, this total, and plus with the next this one, cumulative relative frequency. Go. So by keeping this on to the last value, I will be getting this. The last value would definitely be equal to 1. Okay, now what the relative frequency is telling us, this has been not explained yet. What the relative frequency is telling us, let's see. First of all, we would set some sort of decimal points. I would like to have 4 digits only here again, and similarly here again I'm just going for having only 4 digits. Okay, now what relative frequency is telling us, look at that. It means that 2% or 2.09% of the total observations belongs to this class of age. Similarly, 15.64% of the people belongs to 18 to 24 observations. Then 18.06% of the observations belongs to that range of age, age of 25 to 31. 13.46% people or persons or objects or observations belongs to that group of age of 32 to 38. Similarly, you can interpret all of the percentages, and that is actually the equal percentage and cumulative percentage. Cumulative percentage you would interpret like to have some cumulative figure more or less of age, having the percentage of age into containing different kind of groups. Let's say if I'm explaining this 0.3579, it means that 30.79% of the people belongs to age of 31 and less. I'm doing it again. Please listen carefully. If I go to explain this 0.6020, it means that 60.20% of the observations belongs to the age 45 and less, because it is a cumulative figure. Here 81.61% of the observations belong to the age group of 59 and less. So that's how we can calculate the relative frequency and cumulative relative frequency. So guys, this was the frequency distribution. We have calculated the frequency, we have calculated the relative frequency, and we have taken the cumulative values of the frequency and as well as the relative frequency. So our next job is to do the having pie chart. So how pie chart and why pie chart is necessary, that if you want to show this percentages into some kind of diagram, so you can show these percentages in diagram by taking help of pie chart. For pie chart is very much easy way. You have to just select all these groups along with the labels, headings, go to insert and then go to pie chart. So that is 2D pie and 2D pie in the first diagram I am interested in, and that is actually the frequency distribution. Here you can see the color. If you go for any color, you will see the detail of it. It's showing the gray area is showing the points or the group from 25 to 31, and it contains 216 frequency. That makes almost 18% of the total population. So you can go to any area let's say it is blue. So blue is showing the frequency of having the range from 39 to 45 with the with the frequency of 131, and that 131 contains 11% of total observations. So if and you can see the keys as well, what the areas are expressing. That blue is light blue is explaining the range of 11 to 17. Then the orange range is explaining the 18 to 24, and so on and so forth. Okay, now if you want to have some calculation explained into this box, you can click it on, and by clicking it on, point to be noted that if you can click, the whole circle should be selected. Then you go to the right click, and the right click you can see the data labels. So add data labels, if I'm clicking it, so it would clicked like that. Now all those frequencies, you can see that all these frequencies are now shown in each color. You can show these figures into percentage form. Again, I'm going to click it on, all the values are being clicked on, and here format data labels, and by keeping format data labels you can see many options over there. Series name, if you want to click on the series name would come on, but I'm not interested to have series name. And then category name, you can go for the categories name, but I'm not interested over here. You go for values are already given. If you want to have the percentages, you can click it on, you can calculate the percentage, and so on and so forth. So that is very much easy task now, and you can copy it and paste it into any other Microsoft Office file, like Word or like other file or format of document. So guys, that was the pie chart. So we have done all what we have required almost, except the last one, line graph. So line graph, if I go to again to my chart over there, this is actually my data. So here I can again go for line chart as well. So for line chart I would go for selecting this classes, the insert, and again I'm going to, but now not for scatter point, I'm going to this line or area chart. So for line chart, that would be appropriate. Yes, by clicking line chart I have got the line chart of this frequency distribution. So that is giving you the same information as that was given in the bar chart. So you can see that this is first series, which is ranged from 18 to 24. It is having 187 observations, and similarly you can go for any point, you will be having information about the series and the number of frequency. So this is all about our first assignment, and now you will be given some kind of a large data, and all of you have to do such similar practice into Excel sheet. Thank you very much.